Look at double angle trig identities. These are very similar to the sum and difference identities that we did earlier. Let's take a look. Here are the formulas that you need to make sure that you have handy for every problem that you do regarding double angle. For sine 2 theta, we only have one option. That's 2 sine theta cosine theta. For cosine 2 theta, we actually have three options, and this is because of the Pythagorean identity. The first one is the cosine squared theta minus sine squared theta. And if you play around with the Pythagorean identities, you can actually derive the other two. Cosine 2 theta is 2 cosine squared theta minus 1. It can also be 1 minus 2 sine squared theta. So although there are three options, they all are the same thing basically. They are all cosine 2 theta. The way you determine which one you're going to use is which one is easiest for you to use at the time. If I was doing a problem and I only had cosine, I would use the middle one. If I was doing a problem and I only had sine, I would use the third one. If I had both sine and cosine, maybe I would use the first one. It just depends on what's easiest for you when you're doing the problem. For tan 2 theta, there's only one option, 2 tan theta over 1 minus tan squared theta. Let's dive straight into some examples. Now we're going to pick which double angle formula this represents, and we're going to work backwards to find the angle. So as you can see, this 2 sine 15 cosine 15 looks a lot like this, 2 sine theta cosine theta. So because they look exactly alike, I can plug that into the formula and call it sine 2 theta. Now, we actually have a number for theta. If you look at these two things, they're almost identical. The only thing different is that we have an angle in there. So theta is 15. So instead of writing sine 2 theta, I'm going to write sine 2 times 15. So we have sine 2 times 15, which is the same thing as saying sine 30. And it says to write each expression in terms of a single trig function. I'm going to go ahead and get the value of this. You can get it from your unit circle. Sine 30 is going to be equal to 1/2. Now if we take a look at B, it's in the same format. 2 sine of an angle, cosine of an angle. So this is also going to be sine 2 theta. So we're going to have sine 2 times 5 pi over 12. All right. Now when we do that, we can cancel numerator and denominator. So 2 can go into 12 6 times. So that's going to end up being sine of 5 pi over 6. And then you can look that up on the unit circle as well. If you look it up on the unit circle, you will also find that it will be 1/2. Part C happens to be the same as well. 2 sine of an angle, cosine of an angle. So we're going to set it up the same way. Sine 2 times 0.6. Now this time we don't have an angle that we can find a exact value for, so we're just going to go ahead and do 2 times 0.6, which is sine 1.2, and we're going to leave our answer like that. On part D, we have our first different one. Which one does that look like? Where in my equations do I see cosine squared theta minus sine squared theta? Well, it happens to be one of the cosine 2 theta equations. So 75 is the theta, so I'm going to jump right into my answer. That's going to be cosine 2 times 75 degrees. 2 times 75 is 150, so I'm really finding cosine of 150. And if you take a look at your unit circle, 150 is going to give you a cosine of root 3 over 2. All right, make sure you're writing notes. If you don't understand something, pause, rewind, do whatever you have to do to understand. Also, try to attempt these before, or attempt them again. Just rewind where you see it blank and try and attempt them. See if you get the same answer. We have a couple more examples. We have 2 cosine squared theta minus 1. What does that look like? It looks like this. And so we're going to go ahead and use cosine 2 theta. Cosine 2 times 22.5. If I double that, that's why it's called double angular. That's going to be cosine of 45, which if you check out the unit circle, it's going to give you root 2 over 2. Similarly for f, we see that we have 1 minus 2 sine squared theta. 1 minus 2 sine squared theta gives me cosine 2 theta. So go ahead and put in my answer, cosine 2 times 67.5. If I double 67.5, that's 135, so I'm taking cosine of 135. And if we look that up on a unit circle, cosine of 135 is going to give you negative root 2 over 2. All right, here's our last three. We have write each expression in terms of a single trigonometric function. We should be getting better at this by now, so at this time you should probably try these three out before you see me reveal the answer. I'm going to go a lot quicker on this one. So we have sine of 210 for this one. If we check that out on the unit circle, we get negative 1/2 for that. For part B, it's the cosine 2 theta function, so we're going to go cosine 2 times pi over 12. If we simplify that, we get cosine pi over 6. Cosine of pi over 6 is root 3 over 2. And then for part C, it's actually the same exact thing as part B. In part B, we use that version of cosine 2 theta. In part C, we're using the other version of cosine 2 theta. And it's the same theta, so we're going to actually end up with the exact same answer. Cosine 2 times pi over 12, which gives me cosine pi over 6. which gives me root 3 over 2. All right, as always, ask lots of questions in class, and I'll see you on the next video.